Okay, let's get started. My name's David Currie, and for the next half an hour, I'm going to give you an introduction to the project known as Knative. I'm a software engineer at a company called CloudBees. Many of you may be familiar with CloudBees as the company behind Jenkins, but actually over the last few years, we've been slowly spreading out into other spaces. We acquired a SaaS offering called CodeShip, allowing you to do build in the cloud. Some of you may have heard of the Jenkins X project, which is about doing continuous delivery on top of Kubernetes, and I'll talk a little bit about some of that during the presentation, as that's the link to Knative. And just recently we acquired a company called Electric Cloud, which also does release automation. So really the whole spectrum from continuous integration all the way through into production environments. I actually only joined CloudBees just under a year ago. Prior to that, I worked for IBM for longer than I care to say. And so if you've seen me up on stage before, it may have been presenting on topics like WebSphere and containerization. So I only have a few slides. Most of this session is going to be a live demo, but given the subject, I really have to give a what is Knative. And so the one sentence description is it's an open source project providing a set of Kubernetes native building blocks for serverless. And so if we unpack that a little bit, it's an open source project. It was contributed by Google, announced at their conference this time last year. And so I apologize a little bit that I've deviated from the abstract that I submitted, because the project was only 6 months old at the point at which I submitted the abstract. It's now a further 6 months old, and things have moved on a little bit. And so some of what I'm going to talk about will reflect those changes that have happened in the meantime. By Kubernetes native, Knative only runs on top of Kubernetes. It makes use of Kubernetes concepts like custom resource definitions. The way you interact with Knative is the way in which you would normally interact with a Kubernetes cluster. Probably the most important bit of this, though, is the building blocks part. That if you find yourself doing what I do in the demos with the Knative APIs, then you're doing the wrong thing, because it is designed for people who are building serverless platforms. Okay, maybe you're building a serverless platform. I'd suggest that's probably the wrong thing to do as well, because there are plenty of them out there already, and you should be picking one of those. The purpose of this talk is really to get you to understand what's happening in Knative beneath one of those platforms, and to make you think when you're choosing a platform whether you want to choose one that has Knative powering it. So I guess from the Google front, Cloud Run and Cloud Run for GKE are building on top of Knative, but there are other platforms like IBM's Cloud Functions, Pivotal's Function Service, and their Riff open source offering. Those things are all building on top of Knative. And as with many of these projects, it's about really raising up the value that those projects can provide on top of a common base. Everyone doesn't have to go out and build these components. They can just take Knative off the shelf and build their platform on top of that. And then the serverless part, serverless means different things to a lot of different people. I will make the point later on that this is very much not function as a service. So the things that we are going to deploy here are containerized applications, not functions. Really, serverless here is just about providing a higher level abstraction for developers. If anything, I would say Knative is probably providing platform as a service as much as anything. So there are currently 3 components that make up Knative: serving, build, and eventing. The middle one, build, is potentially going to be removed, so there are discussions in the working groups at the moment about whether it really belongs in the Knative projects, and I'll come on to a moment why that might be the case. So starting with serving, this is the most obvious piece. This is about providing you that ability to deploy containerized applications, to deploy different versions of those containerized applications, It, out of the box, utilizes Istio to provide the ability to route between different versions of the application. It does have an abstraction layer, so you can now take out Istio and use Glue instead, if that's your preference. The build part is about how do I get that containerized application, so how do I get from source code to a container. And then serving itself is all about HTTP traffic. So eventing is then how do I take other event sources and translate those into HTTP that can then be processed using my Knative serving applications. And there are a whole bunch of event sources that are provided out of the box for things like pub/sub platforms, GCP pub/sub, for example. I can have an event source, which is just a timer that's going to run on a periodic basis. I might have SQS as an events that I want to send through and convert those into Knative. And so I can take those event sources, push that through into my Knative serving application, and still get the benefits of that versioning and auto-scaling and the pieces that I get from Knative serving. What it is not, though, is kind of an end-to-end event bus. So it's only interested in taking inbound events and changing those into HTTP. It's not interested in helping you with the outbound side of an event-driven architecture. So the reason that the build bit is potentially going to get removed from Knative is because of this project called Tekton. So in the abstract for this, I mentioned something called Knative Pipeline, which was going beyond that just simple containerized build process that Knative build was going to give you to allow you to build more fully featured CI/CD pipelines. So things where maybe I want to run tests as part of it, maybe I want to do stuff in parallel, and Knative build doesn't help with any of that. Knative Pipeline, I mean, it really hadn't got off the ground at the point at which I wrote the abstract, but a lot has happened in the 6 months since then. One of the things that happened is it's moved out of the Knative project into a separate project called Tekton, and that Tekton project is now part of something called the Continuous Delivery Foundation. So the Continuous Delivery Foundation is now also the home to Jenkins, Jenkins-X, and Spinnaker. So a bit like Knative is Kubernetes native, so Tekton is also Kubernetes native in the same way that it uses custom resource definitions as the means to drive and define pipelines. It allows you to define things called tasks, which are just a series of containerized steps. That's pretty much what Knative build gave you as well. The interesting thing about pipeline is then you can take those tasks and create a graph of those tasks to define your pipeline. And that's where you can do things like run things in series or parallel. You can define the inputs and outputs for each of those tasks so that I can actually run part of my task on one node in my Kubernetes cluster, persist the outputs of that, and then pick up the next task on another node in my cluster. It then has these concepts of things called task run and pipeline run. That's how I actually invoke a task or a pipeline, and something called a pipeline resource, which defines the inputs and outputs for a particular invocation of a pipeline. It is used by Jenkins-X, and that's my interest in this project here. So there are a bunch of folks from CloudBees who are involved in the Tekton project. As with Knative being a building block, Tekton is designed to be a building block. So if you're building a CI/CD system, you could build it on top of Tekton. It's not really designed to be used by end users directly. And so in the demo, you'll see an abstraction layer that Jenkins-X is putting on top of Tekton. Support for Tekton is also popping up in other places. So Spinnaker, for example, is looking to add Tekton support as well. So that's probably enough on the slide front. So let's switch to demo. So I currently do much of my development in Go. So the example is written in Go. This is really just hello world in Go, though. The only interesting things in this little web server are it takes a version environment variable. If I'm doing a HTTP post, then it's going to parse a name out of the body. Otherwise, it's just going to use world. and then it's going to output a message or return the message, which is the version number, hello, and world. The only other interesting thing in this application is that it also takes a port environment variable, so Knative is going to pass in the port that it wants the application to listen on using that environment variable. The thing that then defines my Knative service is this custom resource of kind service. And really the only interesting things in here at the moment are the image that I want to run here. So I've just built that application and pushed it up onto a Docker Hub and an environment variable, which is going to get passed through to that application at runtime. So if I then go to a Kubernetes cluster and I apply that service YAML that we've just seen, it's going to go off and create that service, and I should be able to curl it because it's going to set up a route to that application automatically. I need the name of the application, then it's in the default Kubernetes namespace, and then just the name, the DNS name that I've given to my Kubernetes cluster. And so I get v1 hello world back from my application. So far, nothing that I couldn't have done with a Kubernetes deployment. Let's try rolling out a new version of my application. I'm going to update that environment variable to say version 2 and push that again. And not giving it long enough. Still not long enough. Version 2 is now live. Okay, again, still nothing I couldn't do with a Kubernetes deployment. Where things get more interesting is if I look at the pods that are running and ignore the two broker ones for the moment. But I've actually got a pod running for each of the versions of my application at this point. So version 1 is still running alongside version 2. And so those of you who know a little bit about Istio might think that Istio is now doing the routing between those two. And Knative has this idea of a revision. And if I look, I can see that there are still 2 revisions of my application that are up and running. So that gives us some interesting things. At the moment, I say I have a pod running for each revision, but Knative provides me with auto-scaling, and by default, it auto-scales things back to 0. So if we waited long enough, we would see those pods actually disappear completely. And only when some new traffic comes in that's directed towards a particular revision will it spin up those pods. As I said earlier, though, this isn't function as a service. It's not spinning up a new instance of the container for every request that's coming in. In fact, by default, the concurrency allows for a single container is 100 requests, and it's only going to start spinning up additional instances of the container when I exceed that limit. So let's have a look at how we can play around with that a little bit. So there are these annotations here, for example. By default, it creates just one pod to start with. I can change that to say I want to have at least 2 running the whole time, so don't scale back down to 0. So if I know that my traffic is bursty, but I want low latency, so I always want to have something sat there waiting for a request to come in, then I might want to make that change. So if we apply that and then list the pods again, we can see actually that we still only have 2 pods running because it's got rid of revision 1 because it's now been at least 30 seconds since any traffic came in on that, but it's spinning up a second pod for that second revision. Now I'm going to try and get the autoscaler to kick in. And as I say, by default, it expects a concurrency of 100. Given what my application is doing, it's really hard to get it to scale up based on just returning hello world. So I'm going to scale that back to a concurrency of just 1 and see if I can manage to get it to scale using that. So again, we'll apply that. And then I'm going to use a little tool called Hey to apply over a 10-second period with a concurrency of 100. Just calling that hello world. Oops. I used to use a standing desk the whole time, at which point typing standing up was much easier, but I've got out of the habit. And once that's run, we're just going to see how many pods we have at the end of that. So count to 10. Always takes much longer when you're stood in front of a crowd. That's just the statistics coming back from Hey. See that it's got a bit of a divergence on that. And now I'm wondering whether I mistyped something. What is it doing? Let's try another command prompt. Okay, and so we have 1, 2, 3, 4, 5 versions of the pod this time. Still hard work to get it to scale up to any decent sort of number. So that's an example of the auto-scaling behavior. Let's just set that back. So the next thing I'm going to look at is, by default, we're getting the same sort of behavior you get with Kubernetes deployments, where it was just moving on to the newest revision and directing traffic to the newest revision. What if I want more control than that? Well, this run latest is what was telling Kubernetes that I just wanted to run, or Knative that I wanted to run the latest version. Instead, I'm going to change that to release, and I'm going to explicitly tell it the revision that I want to send traffic to. So if we do get revision again, and we'll take the latest one of those, revision 4, and we'll tell it that's what we want it to route traffic to. In the meantime, we'll also bump the version number up to 3. We're still not back in business there. Okay, let's... Okay, so at that point we should see that we also have a revision number 5. Doesn't put them in order, just to annoy me. If we do our curl again, it's still returning version 2 because I told it that's the route that I wanted it to send traffic to. So what about if I tell it about the new revision that we've just created? So I'll add that to the list and go back and apply that again and curl. And it's still returning version 2 because the default behavior is that it's always going to return the first revision in this list. The interesting thing now at this point, though, is it's also created a route that I can use to get the second one in the list, candidates. So I can now access the new version of my application, do some testing against that before I decide to start switching traffic across to that. And the way I can start switching traffic across is to set a rollout percentage. You'd probably pick a smaller number than 50, but just for the sake of demo, we'll apply that. And at this point, we should see that it starts balancing the traffic between the two different versions. Where's version 3 gone? There we go. And then when I'm happy with my new version, I can take that back out, just leave the new revision number, apply that, and I should just now get my new version 3 the whole time. So that's using Knative to do basically a blue-green deployment. And again, if you've got any familiarity with Istio, that's a whole lot easier than it is to configure Istio to do the same thing. So let's delete that. And let's have a look at build. So this is basically the same thing I had to start with the run latest, except in the configuration section, I've added this extra stanza here, which defines the build that I want to do. And this this is another custom resource. You can even see that it has the API version and kind in here. The interesting things are it's going to build from this Git repo, and the way it's going to build it is using a build template called Canico, and it's going to pass in an argument to that, which is the place that I want to push the image that I've built. And so that build template exists in my cluster. So I can have a look at that. And we'll see that what my Canico template does is use the Canico executor project to build it. And it's going to take that image parameter and it's going to pass it in using the destination option to Canico. So at that point, we can apply our service with build. And if we look at the pods now, this pod here is not actually a pod to run the application, it's a pod to build the application. So we can see that it actually is made up of 3 init containers. One of those containers is going to set up the credentials to access my Git repository and Docker Hub. The second container is going to check out the source code, and then the third container is going to run that Canico image that we saw in the build template definition. And it's just using init containers, as init containers are a good way to get sequential containers running. And then when it's finished doing that, it's then going to go and do the same Knative deployment that we saw earlier. That usually takes a little while to run. So in the interest of time, I'm also going to look at the eventing piece now, and we'll come back to that in a second. So on the eventing front, I'm going to set it up to use GCP pub sub as the event source. And so this is the custom resource to do that. It points at a secret which has some credentials in for accessing this Google Cloud project. The really interesting bit here is this is the topic that I want to listen on in pub sub, and the place I'm going to send the events that I receive on that topic is to the default Knative broker. And then at the other end is something called a trigger. The trigger is going to take the events from the broker. In this case, I haven't set up a filter, so it's going to take all events that arrive at the default broker, and it's going to set up a subscriber, and that subscriber is going to be our Knative service. So I hope it's finished deploying by the time we've finished this. So let's apply that event source and the trigger. Check that we now have the new version of our application running, which is this one here. And then we'll just use the gcloud command line to send a message. That. Oh, there's a new version available. And then, if we look at the logs for our application, there are multiple containers, so we have to tell it which actually has our application in it. We see that it's received the message and output it into the logs. So if we went back and looked at the application, we would see that, I'm going to find it, what it does in that parse body is, so the eventing uses a spec called Cloud Events, which is just a JSON format for events. The interesting thing in the JSON format we're interested in is just the data. So we're taking the data field out of that. It's byte64 encoded, base64 encoded. So we're going to decode that, and then that's the message that we're receiving inside our application. Okay, 6 minutes left to talk about Tekton a little bit. And I'm now in the wrong directory here. So I'm just going to show Tekton as used by JenkinsX. This is a JenkinsX project that's just been created with the JenkinsX quick starts. It's a very simple Node.js application. It's just going to serve up this HTML, and I'm going to change this HTML to say load docs. And we're going to push this up And we're sat on a branch, so I'm just going to use a convenience thing from the Jenkins X client to create a pull request using my ID. And so if we go and have a look at this pull request, we should see that it's going to kick off what it's calling serverless Jenkins, but is actually a Tekton build to build and push this application. And so if we have a look in this repository, there is this Jenkins X YAML file, which you would think might contain the definition of the pipeline it's going to run. Actually, it just says this is a JavaScript application. Jenkins X has this idea of a build pack, and the build pack is the thing that knows how to build JavaScript applications. So if we go and look at the definition of that build pack, which is also in GitHub, here we can find a definition of the pipeline that it's going to run, in particular the pipeline that it's going to run for a pull request. This is not Tekton, this YAML. This is Jenkins X pipeline YAML, and Jenkins X is going to translate this down into Tekton resources for us. Because as verbose as this might look, the Tekton resources are even more verbose. So take a look at that pipeline, and then we can have a look at the pipeline that is created from that. Nope. Do you know what? It's in a different cluster. So helps if we select that instead. So the one we created 1 minute ago. So that pipeline YAML we've just seen gets translated into this pipeline definition, which is pointing at this task. And this task is the one which contains all of the definition of the steps that make up the pipeline. And there are pages and pages and pages and pages of stuff that gets auto-generated from that pipeline. So this is why it's a building block, not something that you should use directly. So with just 3 minutes to go, to summarize, if you're looking to do serverless deployments or CI/CD on top of Kubernetes, then you should consider looking at projects that use Knative or Tekton. We'll skip over the Q&A. I'll be around if you want to ask anything. There's a bunch of resources here. Probably the only things I haven't talked about are so the Riff CLI from Pivotal is very good for a quick way to set up a Knative cluster. The KNCuttle is a nice CLI. If you don't like messing around with CRDs, it's a good way of creating those resources from the command line. But as I say, you should really be using a platform that wrappers all of this up in something much nicer. And then my ex-colleagues at IBM contributed this dashboard to the Tekton project, which gives you a nice UI for viewing Tekton tasks and pipelines as they execute. Wouldn't be a conference presentation if I didn't say we're hiring. We're a distributed company, so wherever you are, we have a job for you, whether it's front-end or back-end, JavaScript, Java, or Go. There are all jobs in those spaces available when I looked yesterday. Thank you very much for your time. Enjoy the rest of the conference. Thanks.